Now, I've had this antenna for quite a while now. I've had it over on the other bench, always kept meaning to take a closer look at this and do a video for you all, so I apologise to the person who sent this in to me, but it's a professional GSM antenna, and it's designed by the, and I'll probably making a mess of the pronunciation, but by an antenna company in Germany called Kathrein. Now, Kathrein is one of the longest running and most successful professional antenna companies in the world, and this is just a small part of the inside of a sector antenna that's made by them. This was taken down because they were upgrading their antennas on one of their masts, and this came to me all the way from Germany, so I thought it'd be interesting to take a look at a professional 3G, 4G antenna that you would find on the inside of those antenna masts. Now, when I first got these, I made the assumption that possibly these smaller ones were for a different frequency from these. I was thinking that these were probably around 1800 megahertz and the smaller ones are up into the 2 gigahertz region, but they are not. They are all the same frequency, and basically the bigger ones, these are all ground plane here, the reflectors on these antennas, and it's just to increase different beam width. So this one has a smaller beam width, a much narrower field of operation than this one here, for instance. So having all these together in one sector antenna, multiple elements, you're able to have greater coverage over a wider area by using these different elements with different beam widths coming out of the sector antenna. And to be honest with you, these look really elaborate, but they've got very, very simple driven elements down in here. So this is one of the larger ones that I've got then, and taking a look at the outer elements on this, you can see that they're not quite square, and that's not because it's been banged up and squashed on shipping. That's done on purpose. Basically, when they're all lined up in the sector antenna, all the elements, this will have a different radiation pattern, for instance. So you know, it's all to do with the radiation pattern, and these are the two driven elements from the inside of there. Really, really simple elements, and they sit like this on the inside. They do not touch, and that's the main driven elements on one of these antennas. And the smaller one is much the same. You can see this one is more square, but again the elements, they are a little bit smaller, but they are the same length and I believe the same frequency, and they sit crossed like that. They do not touch again, and they're also insulated from the ground of basically the casing of the antenna, the ground plane of the antenna, and they just sit crossed like that. Really, really simple antennas, and very interesting. But you'd get about you know, possibly 10 of these elements in one sector antenna, maybe more. It just depends how much coverage they want to get over a certain area. Now, this is one that's complete. This is one that's mounted to, it's got its back reflector on there as well. All this is ground here as well, and the driven elements crossed over in the middle there. And basically it's two antennas, as I said, and you can see here at the back we've got the two pieces of coax coming out here. Each one of those elements has its own coax. The coax is ground down on to this back reflector here and onto these elements here, and they have this nifty little combiner at the back there to combine those two coaxial cables into one output. This is something that I've put on myself so we can test this antenna, but there's no components in there. It's completely passive, and all to do with the pattern here on this little PCB to combine those two coaxial signals in there, and obviously to keep it at 50 ohms as well. So really interesting and extremely simple. You would have thought, you know, those big antennas on the mast there, they'd have some kind of active combiner on there, but no, just completely passive. And this is one of the bigger ones here, again with its back reflector in place there, and you can see those elements in the center, the main driven elements there. And again, we've got a combiner on the back with the two coax cables, exactly the same combiner as on the smaller ones, but again, as you say, it's all passive. Very interesting. And I've put this coax on the back so we can also test this one. But as I say, they are all the same frequency. We're just getting a different beam width coming out of these depending on the area that you want to cover. But from a design point of view, I don't know what the official name of this antenna is. I've never seen anything retail that even comes close to resembling this. And when I was first shown a picture of one of these, I did think it was some kind of bike one at first, just from the pictures, but it most certainly isn't. It's you know, it looks more like some of those crosshair antennas that people build for quadcopters. Very simple indeed. And I can't find any individual information about one of these elements and the gain of one of these elements. They all seem to be you know, as one sector antenna with you know, different elements inside. So you might have a sector antenna with say 6 active elements inside, and you'll get the gain data from that. But I can't find anything on the individual ones. And if I had to guess, you know, a crossed arrangement like this, I would probably say each one of these is outputting, I don't know, 6, 7, 8 dB, no more than that on an individual basis. I wouldn't have thought, not with that simple cross design there. But it's really interesting to see things like this from the professional you know, antenna makers. And here is a sample of the coax that he sent me, and it's a really nice quality feeling semi-rigid coax. This, it you can't really tell on camera, but just the feel of it, you can tell by feeling. It's not like the Chinese stuff that I get off eBay. It just feels really nice, a little bit like the difference between silicone wire and normal PVC wire. It just feels really nice, really good quality coax. So I'm going to be making some cables up with all that. And here are some of the nuts that came with this to hold all the antennas together onto the reflector like that. But I've only got 2 of these cases. I suppose I could make a couple of cases up, possibly, just to get some of these up and running, because I want to keep a couple of these here in the lab to use over on the bench. Really nice reference antennas. But there again, I haven't tested these yet on the network analyzer, so let's go over onto the test bench and see what they look like on the network analyzer, and see if I'm right when I think these are 1800 megahertz or not. So we've got the smaller one to test first, set up here on the test bench. So let's take a look at the network analyzer. So here we are on the network analyzer then, and we're scanning from 500 megahertz all the way over here, all the way up to 3 gigahertz up here. I've got the cursor in the area that we're interested in, and we can see it starts working really well from about 1.79 gigahertz around there, all the way, a lot wider than what I thought it would be, all the way up to about 2.2 gigahertz, maybe even 2.3 gigahertz. So really nice response from this professional antenna. I mean, if you picked up an eBay antenna like this with a response like this, I'm sure you'd be really pleased with how this would perform. Really nice frequency response, and a little bit wider than what I thought it would be as well. So next we've got the larger one on the test setup, and again it's looking pretty nice on the network analyzer. So here we are with the larger one then, and we're getting a little bit different response from this one seems to be aimed at around 2.1 gigahertz, but if I move the cursor, you can see we start getting a good response around about 2 gigahertz there, so about 2 gigahertz, dipping down 2.17 gigahertz there, and then go up to about 2.3 gigahertz. So again, in the general area that the small one works at. Remember, testing them on a bench like this isn't really the best way to go about it, but as you can see from the test with both of them, they're all hitting the same kind of point of frequency. Not quite as wide as the smaller one, but again, a really nice response. So if you picked up this antenna on eBay, just like the first one, I think you'd be pretty happy with it. So this was just a short video then, just to take a quick look at this and see how well it performed and what it looked like on the network analyzer. And I think you'd agree, it looks pretty nice on that network analyzer. And you know, it is a pretty simple antenna when you look at the basic construction of it, but again, yeah, it's nice. And I think that maybe we'll come back to this in the future. Maybe I'll have a go at etching this out on some PCB board, or coming up with something that we can fabricate and use pretty easily. I did today because I was interrupted. Somebody was doing some building work outside, so I just took some brass wire and that with this one. I thought I'd have a go at quickly constructing a 2.4 gigahertz one, just guessing the measurements, really taking the measurements from this and just trying to have a guess at getting the measurements for 2.4 gigahertz. But this one's failed a little bit. It's only coming in around 2.3 gigahertz, but you know, you can have a go at making something like this on your own at home, but I think etching these parts of the elements is the way to go. But yeah, an interesting antenna. So I hope you enjoyed this video. If you did, please give it a thumbs up. If you want to help support this channel, then please feel free to pop over onto Patreon, and hopefully you'll join me on the next one.